Hey y'all, happy Wednesday. So glad you're here joining us for our math class today. If you remember on Monday, we were talking about adding and subtracting fractions with like denominators, where the bottom number was the same for both the first fraction and the second fraction. Sometimes there were 3 or 4 fractions. And then yesterday we spent some time practicing on our own. Well, today we're going to start learning about how we handle it, what we do when our fractions don't have the same denominator, the same bottom number. So a lot of times in real life, you'll end up with denominators that are different, like 1/3 and 1/2, and have to add those together. Well, today we're going to start seeing what we do and how we handle that and how we make that work. Before we begin that, we're going to start reviewing some mental math of adding fractions with like denominators. Then we are going to go into some equivalent fractions. Remember, equivalent means equal. So we're looking at some fractions that are the same, even though they have different numbers. And then we'll dive into our lesson for today. So without further ado, let's kickstart this. Here we go. All right, so we're going to start with 1, 2, 3, 4, 5 different problems that I want you to do in your head. Here's our first one, 1/3 plus 1/3. 1/3 plus 1/3. Absolutely, that is 2/3. Stellar. Awesome. I love it. All right, let's try another one. 1/4 plus 1/4. What is that? What is that? Absolutely, it is 2/4. And we remember that when we add fractions with denominators that are the same denominator, all we do is add our numerator. 1 plus 1 is 2. Then our denominator remains the same. So 1 plus 1 is 2. Our denominator is 4. Let's take a look at our third problem. Something a little bit tougher now. 1/5 plus 2/5. All right, give that one a shot. What is it? Do it in your head. Absolutely, that is 3/5. Because 1 plus 2 is 3. Our denominator is the same. So there we go. All right, we're going to get with a little bit tougher one now. And I love this one because it is actually going to have 2 different answers possibly. So we are going to do 3/7 plus 4/7. All right, give that one a shot in your head. I'll reveal my answer in just one moment. Awesome. So I know our denominator is the same, so our denominator will be 7. Then 3 plus 4 is 7, so our answer is 7/7. Now, if you're like me, you remember, hey, 7/7, anytime our numerator and denominator is the same, that means it is going to be equal to 1. We also remember, hey, when we are reading a fraction, we can read 7/7, but we can also read it as a division problem. That line in the middle is a division problem, so we have 7 divided by 7, and 7 divided by 7 is 1. Awesome. Awesome, awesome. All right, now we get into a really tricky problem. I hope you're ready. We're going to take some time to solve this problem. All right, so try and solve this in your head as best as you can. Pause this video here, take some time to think about it. When you think of an answer, come on back together. If you want to share your answer with someone at your house or wherever you're doing this, a car, neighbor's house, the store, or school, wherever you happen to be, that'd be awesome. So pause this, solve this, and then come on back when you have an answer. Awesome, welcome back. So I bet you've noticed, hey, we have different denominators here. We have a 4 and a 3. That means we can't just add our numerators because 1/4 and 1/3 are not the same unit. But what I did notice is that this one and this one have the same denominator. So I could do 1/4 plus 3/4, and 1/4 plus 3/4 is 4/4. And that is equal to 1. And then I also noticed that both of these 1/3 and 2/3 had the same denominator. 1/3 and 2/3 equaled 3/3, which was also equal to 1. And then if we add 1 and 1 together, Mr. Olson walking by, we get, absolutely, Mr. Olson, we get 2. So when we add all this up, and I'll zoom out just a smidge here so we can see it. Maybe it goes far enough. when we group our like denominators together, we're able to add our like denominators, which happen to both equal 1. Once you got to that point, you could add 1 and 1 together and get 2. Awesome. If you have any questions about this, let me know. I'd love to help you out. Otherwise, I'm going to leave this here for just one moment. Slide that down just a smidge. Maybe that'll let us go. And then we'll move on. So up next, we are going to rename some fractions. That's where we are going to find an equivalent fraction, and we are going to rewrite it with the largest units. So that means our number on the bottom, our denominator, is going to be as small as possible. So I want us to start with this fraction right here, 2/4. What is 2/4 equal to? Well, I know 2/4. If we divide both the top number and the bottom number by 2, 2 divided by 2 is 1, 4 divided by 2 is 2, so our answer is 1/2. Let's try one more of these. We're going to convert 3/6. We're going to rename that to a fraction with the largest denominator possible. In this case, we know that both 3 and 6 are divisible by 3. So we can do 3 divided by 3, and 3 divided by 3 is 1. We can also do 6 divided by 3, and 6 divided by 3 is 2. So 3/6 equals 1/2. Now, I had a great scholar this morning who drew this out. He said, look, Mr. Spencer, I'm going to split this into 6 pieces, and I'm going to shade in 3 of them. And then do the same size box, but instead, just split it in half into 2 pieces, and then shade it in 1/2 of them. And he said, look, those are the same. I was like, absolutely. 1/2 is absolutely the same as 3/6. And I love being able to illustrate this so we can see this in many different ways. Rather than just looking at it with numbers and mathematically, we're also able to draw pictures and diagrams and use our words as well. Awesome. All right. Now I'm going to pull out one of these right here. And this is our problem to kickstart us with today. Now, I don't know Mr. Beck, and I am so sorry. I should have changed this before I wrote it. I want to change Mr. Beck to Mr. Barton. And down here, we have to change Mr. Beck to Mr. Barton again. And now we have a problem that is much more fun than some Mr. Beck. And our problem that we're going to take on first today says this. 1/9 of the students in Mr. Barton's class list red as their favorite color. Twice as many students call blue their favorite. And 3 times as many students prefer pink. The rest name green as their favorite color. What fraction of the students say green or pink is their favorite color? All right. So let's take a look. I want you to try and solve this, but before we dive in and solve this, we are going to say, okay, what fraction chose red? Red was 1/9. What fraction chose blue? Well, that was red times 2. What fraction chose pink? That was 3 times as many as red. And then what fraction chose green? That was the rest. So first we got to figure out what fraction chose each, and then we're going to say which one chose green or pink. So our answer, we're going to have to take these two together and get our answer down below. And I guess I should zoom out just a smidge there, slide it up. There we go. All right, so take some time, take about 4 or 5 minutes, try and solve this problem. Then we'll come back together once you've got it. Pause our video here and jump back in once you're ready to go. All right, welcome back. So I'm going to take on, we know that 1/9 of the students in Mr. Barton's class pick red as their favorite color. And I'm going to draw a picture up here so we can keep track of this as we go. Now, I know we're looking at 1/9, so we must be dividing this into 9 pieces. 1, 2, 3, 4, 5, 6, 7, 8. Hopefully, by the end of 5th grade, I'll be able to draw it perfectly, but we did. So one of these is going to be red. There it is. And that is 1/9. So then we need our blue, which is times 2. We're going to take our red, which is 1/9, times 2. And we remember when we multiply by a whole number and a fraction, we have to turn our whole number into a fraction. Like we talked about on Monday, we put a 1 because that is 2 wholes, and a whole is represented by a 1. So we have 1/9 times 2 wholes, which equals 2/9. So blue is 2/9. And then for pink, we are going to take our answer, the number of people we had up here for red, which is 1/9, and multiply that by 3. And we remember, when we're multiplying a fraction by a whole number, again, we need to put our 1 underneath the 3 because that turns it into a fraction. 3 wholes, 3 over 1. And then we multiply straight across. 1 times 3 is 3. 9 times 1 is 9. So that would be pink here. Is 3, 9. So then we need to figure out what is left. Well, look at our drawing. It is super simple to find out what is left. The rest is green. How many pieces are there? There are 3 pieces out of 9, so 3 9s. The other way we could have solved that would have been to take what we had, the red, the blue, and the pink, which was 1/9, plus 2/9 plus 3/9, and 1 plus 2 plus 3 is 6. Our denominator was the same the whole time. And then we would have to take the whole, which is 9/9 minus 6/9. And 9 minus 6 is 3. 9/9 minus 6/9 is 3/9. And we are out of the picture there. Sorry, there we go. Now you can see that. But wait, our question says, what fraction of the students say green or pink is their favorite color? So that means, we've got to take our answer here, 3/9 and 3/9, and add those together. So then we're going to answer, we're going to do 3/9 plus 3/9, and that is going to be 6/9. Now, when we take it one step further, we're going to want to come up with an equivalent fraction with our our largest unit possible for our denominator. So we're going to say, what can we reduce, or what can we make 6/9 into? Well, I know both 6 and 9 can be divided by 3. So 6 divided by 3 is 2, and 9 divided by 3 is 3. So there is our answer, 2/3 or 6/9. It's the same. Now, I want to challenge you to take on this next question as best you can. Spend 5 or 6 minutes on it. And it says, if 6 students call blue their favorite color, how many students are in Mr. Barton's class? And I'm going to use our picture to start us off here. Let's say the blue part here means there's 6 between these 2 boxes, and that is where I'm going to leave you. I'm going to have you solve this. If you have questions about how to solve this one or want help, let me know. Pop in tomorrow during our help session on Thursday. I'd love to see you there. Or send me a message, text, and I can help you out as well. Awesome. So that was our kickstarting application problem for today. Now I want us to dive into our notes, and we're going to try some things out. If you have a whiteboard, that is super cool as well. I'm going to do it in my notes, so I have this forever and always. You can do that there as well. But this first part, I'm just going to write down. I want to know the answer to this problem. What is 1 adult plus 3 adults? Absolutely, that is 4 adults, because 1 plus 3 is 4, and then our unit stays the same, and our unit just happens to be adults. So let's take a look at a partner problem for this. We would have 1/5 plus 3/5. And again, that is going to equal 4/5 because our unit is the same. We have fifths and fifths. 1 plus 3 is 4/5. Awesome. Now we're going to take on a little bit trickier of a problem. And that problem is this one right here. 1 child plus 3 adults. What does that equal? Well, unfortunately, we can't combine our child and our adults, so we really don't know what that is. We don't have an answer. There's no way to come up with one possible solution. Children and adults are not the same thing. We must replace units that aren't the same or unlike units with something that is equivalent to the unit to add. What do you think is similar about children and adults? Sorry, yeah, children and adults. What is the same? What is common about that? Yeah, they're both people. So what if we change this to 1 person plus 3 people? Now that we have changed our units from child to person and adults to people, we have 1 person plus 3 people. It's all the same, right? We got people. How many people do we have? We have 4. We have 4 what? We have 4 people. So we need to come up with a common unit. And when we're talking about fractions, our unit is going to be our denominator on the bottom. So here is our first problem of the day. And it's really the only problem we're going to take on. But I want you to take this on and tell me, well, I'm going to write it first. That would help quite a bit if we all saw this problem right here. 1/2 plus 1/4. I want you to think about that. Can we add 1/2 and 1/4 together? Is it possible? Is it not possible? Well, just like this, we can't add 1/2 and 1/4 because the units are not the same. So let's first make like units. Now, we could fold some paper, but it's kind of hard to fold paper through the computer, so I'm going to draw some boxes and cut them up with my marker instead. I need 2 boxes here. I need 1 box here. And I need 1 box here. They are the same size box. And I am going to cut my first box vertically. And I am going to shade in 1/2 of it. And that's my 1/2 right there. There we go. And then I'm going to take my 1/4 over there. And I'm going to cut this into 4ths or quarters horizontally. And then I'm going to shade in 1 of these. Now we have 2 units here, or 2 halves here, and 4 quarters here. What if I split this into quarters separately? What if we pick this one up and put it on top of this, and it looks like this? We've now split this into quarters on top of that. And how many total pieces, how many total shaded parts are there? There are 4, 1, 2, 3, 4 shaded parts now. And there are 8 total parts. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Did the amount of orange we had change? No, the amount of orange didn't change. I didn't add more. I didn't erase any. And did the amount of area of our box change? No. Think of this like when you have a pizza. It doesn't matter if you get this pizza, you get a large pizza. It doesn't matter if you cut it in half, or into quarters, or into 8 pieces, or into 16 pieces. Even if you are really hungry, cutting it into 16 pieces doesn't mean you have any more pizza. You still have the same amount. Just like here, we had the same amount, and we have created an equivalent fraction. Now, since we put this one over here, we're going to take what we had over here in blue and put it over here. There we go. Now, how many shaded parts are there now? There was one. Now there are 2 shaded parts. And there are 8 total parts. Well, look at that. Now that our denominators are the same, I gotta slide that up a little bit. Slide it over here, I guess. There we go. Now that our denominators are the same, we have an 8 here and an 8 over here. We can add our fractions together. So we can add 4 eighths plus 2 eighths. 4 plus 2 is 6. And then our denominator is 8. Absolutely. But before we do that, I want to see if we can rename our fraction here with a different denominator. We want to come up with the greatest units at the bottom, the largest units possible. Is there something that we can divide both the numerator and the denominator by? Can we divide 6 and 8 both by something? I think we can. I think we can divide both by 2. And remember, if we divide the top and the bottom by something, by the same thing, it means we will come up with an equivalent fraction. So 6 divided by 2 is 3. 8 divided by 2 is 4. So our answer here is 3/4 or 6/8. It is the same thing, because we had 4 eighths here. We added 2 more eighths. But watch this. What if I took my 4 eighths from over here, and I moved them in here? And now I'm doing this in bright yellow. If you're going to shade this in 2, please shade it in with a different pattern or a different color. Well, look at that. I took my 4 boxes here, put them over here. But if we get rid of this red line, now look, we've got 1, 2, 3 quarters of blue, 3 sections of blue, and 1 section that is empty. So 3 sections colored in, 1 section empty in the blue box. And we have illustrated that our answer is also 3/4. We could look at also there, let me say that again. When you include the red line, we then have 8 sections. We have shaded in 6 of them. Awesome. Y'all, that is it for today. I know we went fast. I know we went hard. I know we spent some time solving some problems. If you have questions, let me know. I'd love to help you out. But other than that, y'all have an amazing day. Remember, there is no school on Friday. It is Parent-Teacher Conference Day. If your parent would like to meet with me, Ms. Hayden and Mr. Barton, they absolutely can. There should be a link in their email. I will also post a link on the top of our Schoology page by the end of the day today. If they'd like to schedule a conference, let them know. We are happy to meet for good reasons, for not so good reasons. If you are concerned about your grades and your parents want to meet with us, we'd be happy to. If your parent just has questions about what is the rest of the school year going to look like, we'd love to meet with them too, or what 6th grade might look like. But I'll put that link at the top of our Schoology page. Other than that, I will see you tomorrow if you stop by our help session. Otherwise, I will see you next week. Have an awesome day, y'all. Goodbye.